In this video, I'm going to go through some worked examples for the solution set of a linear inequality. We won't be solving linear inequalities yet. We'll simply be taking what's already a solution and writing it in the three different ways that we're using to represent the solution set. Now, if you didn't watch the previous video, it might be a good idea to, because we went through the notation, and especially the difference between, say, being greater than and being greater than or equal to. But just to review that, with a graph, we're going to be using this parenthesis if it's not equal to, and a bracket if it is. And then when we bring in the idea of negative infinity to positive infinity, we can use interval notation, again using the parenthesis if 5 isn't included in the set, and the bracket if 5 is included in the set. And then with set notation, we used braces. So again, this was what we did in the previous video, and I'm just showing it here as kind of a review. So here's our first inequality. Please pause the video and try to represent this set of values using a graph, interval notation, and set notation. Well, here we want to have all the real numbers that are less than 2/3. So as a graph, we would have a parenthesis and then shade to the left. And we would just write 2/3. There's no reason to put a 0 anywhere here every time you draw a number line. Sometimes some students have been told to do that. I'm not sure why. Here it is in interval notation. And again, we have the parenthesis because 2/3 is not included in the set. And we go to negative infinity, and again it's curved because there is no final negative infinity value. And here's the answer in set notation. Here's another. Please pause the video and try to write the three yourself. In this case, we have greater than or equal to, so we're looking for numbers that are greater than or equal to 12. On a number line, we would have the bracket at 12 and then shade to the right. Here's the same set in interval notation and in set notation. How about this one? Here we're looking for all real numbers that are less than 0, so that's going to be if the C at 0 and then shade to the left. Here's the same set in interval notation and in set notation. Here's another. We'll need a bracket at 8 and then shading to the right. Again, with interval notation, a bracket and then the idea of infinity. And here's set notation. Please notice that our variable was a t, and so for set notation, make sure you're using a t also. Try this one. So here's our solution as a graph, and if you shaded to the right, then you're thinking of the inequality symbol as something that points. And the inequality symbol doesn't point. It's a relationship. And so this is saying we want the real numbers that are less than -1. And those are the numbers to the left of -1. So again, this isn't about pointing. It's about a relationship. The same set and interval notation would look like this. And then here we would have set notation. Here's another. So here we're interested in all real numbers that are greater than or equal to 0. And that's going to be that set of numbers. These are the numbers that are greater than or equal to 0. And again, it's not about pointing. Here's interval notation, and here's set notation. Again, please notice that since y was the variable we began with, it's the one we use. The other thing is, when you write in set notation, we always take the point of view that the variable will be on the left. But notice these say the same thing. Here we're saying 0 is less than or equal to our real numbers, and here we're saying our real numbers are greater than or equal to 0. That's the same relationship. So in set notation, the variable is usually on the left. Well, I hope these worked examples may have helped with any issues you were having with the solution set for inequalities.